Good morning, all. I'm Krishnaswamy, and he's Aditya. Um, and thank you, Sai, because whatever I think wherever he left, right, I'm going to pick it up. I'm going to say that all those are applicable to infrastructure as well, right? So actually, he made my life easier by introducing all the patterns already to you. I'm just going to pick up saying that hey, it's also relevant to infrastructure, right? Let's see that. So before we get into see right how that pattern is going to help and everything, right? Uh, First, let's see some of the symptoms, right? I'm going to show or talk about some of the symptoms, and if you see that in your code base, or if you're facing that right now in your code base, right, maybe you can raise your hand so that I can see whether how many of you are actually feeling the same symptoms what I also felt, right? um, First symptom, when managing infrastructure as a code and trying to make an change management. So somebody is asking you to introduce a new change or adding a new module or something, and you felt like, where do I start? Where do I go? Or which one to change? If I change it, I have to change it in multiple places. I don't know what to do, how long it's going to take. How many of you face this, right? And if somebody comes and saying how fast you can deliver this or how soon you can do this, will not even have an idea, because for this change we need to really look into our code base to understand where are the places I need to make the change itself. It's like this, literally like this. So standing here, you don't know where to go, reading all this signs, and still you don't know where to go, right? Okay. The second symptom, you are trying to deploy something into in an environment. It could be a dev environment, qa environment, staging environment, and in the middle you are realizing that hey, this environment seems to be completely different from the other environment, because somebody has actually ran the other set of scripts, and I need the other person who did that particular change. Without that particular person, I don't think we're able to do this. Or this environment is completely different, where I need to use that particular version, this particular version of software that is needed, then only I can complete this. How many of you face this situation, right? These are all day in day out. If you're an infrastructure consultant, if you're dealing with infra, right, you can't say that every environment is same. Every environment is actually different. If it's same, right, then that is actually anomaly, right? We are in that state. Okay, let's talk about the third symptom. And how many of you face this scenario where you're looking for some script to run to fix something, and somebody is giving you floppy disk saying that hey, the script is in this floppy, take it up and run this, it will work. It's very old, outdated, and you don't even have confidence to run it, and you don't know whether the floppy disk is still working or not, right? So then taking it up and putting it up, and then you are going to believe that that is going to bring you or save your production system. Okay, I'll take how about this symptom. This is an interesting symptom where this is one of the VM or a server where a lot of things are configured like this, and you don't know who configured like this. But what you all know, right, if I pull a particular plug, it's not going to work. And this could have been done by n number of people, right? That particular person may be in the organization, may not be in the organization, the team would have moved on, everything, right? So to change some setting here, you need to figure out, and then you need to pray basically, and then change it. How many of you has actually faced the system or still facing this in day-to-day life? Cool. And this is another symptom where you say that hey, I've actually done infrastructure automation, I have everything as a code, and I have everything with me. And if somebody comes and asks you saying hey, there's a similar project coming up and your project also seems to have using the same thing, can you take the script and then create another environment similarly like this? Then only you're erasing all these missing stickies, all the to-dos. Hey, I wanted to do that, this that, and you have this entire pile of stickies which you would have not even had time to implement, and it's all there. Without doing this, you won't even able to take it any further. Have you faced this? Okay, so if you have faced any of this symptom, right, in this talk, what you're trying to say is, right, there are some anti-patterns which is kind of taking yours towards that. So if you can come out of the anti-pattern, and then if you try to do it with a proper thing, right, you may be able to come out of this. Right. With that, I'll just give it to.
Thank you, Krishna. Hello, all. Good afternoon. I'm Aditya. Hope I'm audible to everyone, right? Cool. So, let's see some anti-patterns. So, the first anti-pattern is shared libraries. I think most of you know what is a shared library or a shared module is, right? So, you put one common code, right, into one location and use it across different applications or projects, right? So, that's a shared module or a shared library. So, for example, right, we have 3 projects or 3 applications, okay, and we are using shared modules. And suppose I get a requirement which is very specific to project A, and I have to roll out a new feature in project A. I'll be making changes to the shared module, right? So it will work for project A, but it might break for project B and C, right? So what do you do in such cases? Sorry? Correct. Yeah, we'll come back to that. So the quick solution for this is versioning, right? So I create a version which is specific to project A requirements, right? I'll name it the latest version. I'll be using that version for project A. For B and C, I'll be using the old version of the module, right? So this solves the problem, right? So what exactly happens after you introduce version is this, right? If I have n modules or n different components and each running on different versions, and if I have to deploy it across different environments, this is how it would look like, right? You'll be in a situation where you don't know which version is running in which environment, right? So how do we solve this? Okay. That's even bigger mistake. Let's see. Okay, let's see the solutions. So there are a couple of solutions, and one of the solution is independence. So what do we do here is we place the modules along with your project code. So we have one instance per your project, and whatever the changes you want to make for your project, you'll be making changes to that module, and you'll be rolling out with that project. You'll be rolling out with your own speed. So there is no dependence on other projects, right? So this is one way. And the other way is using monorepos. So in monorepos, right, you'll be having all the projects code and including the modules at one place, right? So here, if you're going to make a change to the module, right, so it might break for the other two other projects. So it's here, since there is no versioning, right, I'm putting some I'm enforcing some policies, some discipline on the developer to make sure that whatever module is writing, right, it should be compatible for all projects. Wherever it's being used, it should be working across. So you should be writing the tests in such a way that any such discrepancies or inconsistencies are detected and fixed. Okay, so these are the two solutions. So what do we conclude here? So we are not saying use multi-repo or monorepo. It actually depends on your organization needs, your business strategies, right? So both of the things, both of the solutions works, but it depends on your requirement from your projects.
So I think if you see one more pattern in all these two solutions, what you're trying to say is, right, don't differ anything. So the moment there's a change, right, and then instead of your just doing it for only for your project need or only for that, and then delaying that, applying it for the other teams, you will get a gratification now saying, hey, I've done my job, I'm done with that. But that is going to come back very strongly later point in time when somebody else is trying to upgrade or somebody else is going to do it. the cost of that delay is going to be multiplied, and then somebody is going to pay the cost. So just an example, right? I think if you go to that dependency thing, whatever we had, right? So in that, if you take an example of a security vulnerability in one of the versions which you need to fix now, the only thing what you have done is, right, at that particular point in time, you felt like one team who want to do it, right, introduce a newer version for their team. They've actually applied that particular security fix and they're happy now. But all the rest of that entire organization or the entire project, right, they are stuck on to that particular version. And now to do that, right, that entire organization is going to do a pass. I'm not going to do anything for this next sprint. I'm just going to do the security fix because it's a very urgent thing. How many of you done the same thing for log4j, right? It's the same thing. So the thing is, right, we ourselves actually create the problem in first hand by defining version, by deferring that, applying it to the other projects. So rather than that particular team taking an extra a day or two, or maybe 3 days, 4 days, and doing it for the entire project, that particular person would have done it only for their team. In that, what happened, right? Now entire weeks of time for the entire project has to pause, and then they have to roll out that thing. It has been magnitude into that. So don't differ. So when it comes to infra, right, try to keep sync all environment as soon as possible. If you're rolling out a change, do it for all environment. Don't even delay that particular thing saying that, hey, I'll do it later. To make us this analogy very simple, right, think of this way. If you're cooking, and then if you want to wash the all the utensils what you used for cleaning it, right, it is very easy to clean right after the cooking. If you keep that thing and if you wanted to clean that thing later in the day or the next day, right, you need to put in so much effort to clean it off. It's the same thing is going to happen here. So don't delay.
Okay, thank you, Krishna. So let's move on to the next anti-pattern, which is operations mindset. So let's see what it is. So in the old times, right, if your boss or your management asks you to deploy a server, application server or a web server or a Kubernetes cluster, whatever it is. So what do you do generally? You provision the VMs, right? You first provision the VMs, you configure it, you deploy the application, you pin the version, you install the dependencies, you deploy the supporting tools, right? And then you manage it. You keep the server running, you apply fixes, you apply patches, you roll out new deployments on the servers, right? So what's the issue with this model?
Is there an issue? Do you see any issue in this model?
Okay, so one issue is if you keep a production server or any server running for a long time, right, there's a high chance of changes. You might be doing changes either manually or by a script. So for example, right, you may do a manual fix to fix a production issue or to fix a failed pipeline, right? The general tendency is you log into that mission, fix it, and then you don't automate it for sure, and you don't even document it most of the times, right? So these things, right, or even on automation. So you write a script for deploying something, you run it on one server, but you fail to run it on the other server, right? So all these changes will lead to something called configuration drift. So with this configuration drift, I'll be creating Snowflake servers. So Snowflake servers are the servers that I was talking about, right? So the servers which are different from the others, right? So these Snowflake servers are very difficult to reproduce because they are looking different from the others, and all of your automation, your tests will be failing on these Snowflake servers. So like I said, sorry, my bad. So these Snowflake servers are all created using because of manual interventions that you're doing uh, for any ad hoc fixes that you're doing, right? So this results in low confidence on your code. You're not sure that your automation will work or not. You're not sure that your test will work or not, right? You're not sure if your script works across all the servers or not. And definitely these Snowflake servers are non-reproducible. You cannot reproduce a issue which is having in one server. You cannot do it in other server, so you can test it across, right? So how do we solve this problem? Okay, so it's not about the tools we are using. So it's about how we are using the tools. It's actually about the mindset, how we are using the tools. So one way to solve this problem is using the modern engineering practices. Let's see those practices. So this is the legacy way I was talking about earlier. So the new way, the modern engineering practices says that you follow application development principles and you apply it to infrastructure code. So here I'll be using multiple stages. Like I'll have a lint stage, a test stage, a build stage, package, deploy, and promote. So I can use various tools across different stages. I can use Open Policy Agent for linting, Ansible Molecule for testing my playbooks. I can use Packer along with Ansible and Chef to create server templates or AMI images, right? So these images I can promote across different environments. I can pass environment specific configurations or application specific configurations during the bootstrap time of the VM. So this is how we promote. We can apply the software delivery practices to infrastructure code. So what are the benefits of using this model? So you can have dynamic configurations. So you can pass, like I said, we can pass the environment specific or application specific configurations during the bootstrap time of the VMs, right? And eventually consistent because my server template is the same image I'm promoting across different environments and different servers. And ephemeral. So if I have to roll out a new version of my application, what do? I change my Chef or Ansible code. I'll use the latest version. I'll run the same pipeline. It will be creating a new server image, and I'll be creating new versions, new servers from that image, and I'll be decommissioning the older servers, right? And self-discovery because no configuration is baked into the server image, and since I'm pulling it during the bootstrap time from the cloud init script or from anywhere else or from the environment variables, so it's discovering. I'm making my image discover those configurations during the bootstrap time, and this will help in creating Phoenix servers. So Phoenix servers are those servers where you can confidently destroy them and confidently bring them back with the same version and with the same application, the software and its dependencies. So this way I can say that I have a consistent application across all servers and in all environments, right? So, yep, I'm done. Krishna, you can take it forward.
Yeah, I'll talk about one more anti-pattern, which is I'll say it's a component organization. Yeah, but let's just define what are components, right? If you take an environment, right, these are all just some of it. You might be using all these things, or you might have more than this, or you might have lesser than this, or whatever be it. But it's a typical thing, right? You have a Kubernetes cluster, you have a database. Database could be self-managed, or it's an RDS, and you have Elasticsearch, or you have networking components, monitoring, DNS, firewall. But whatever be it, right? All these things together is an environment, right? You need all these things to do it. Now, these components, right, what we saw, right, has a different life cycle. What I mean by that is, right, there is I'm saying this as day 0, day 1, and day 2. So day 0 is bootstrapping. So bootstrapping is the day where you bootstrap all these things together. So during this phase, what you need is, right, you need a automation script which creates everything all together, right? Because you will be destroying and then recreating it, and then you'll be destroying and recreating it again and again, again and again. But you need some kind of a scripts which actually does everything. It's a single go. You may not have versions to do that. So if you talk about the day 1, right, let's say when the development is happening on that, let's say the dev teams have started using it, in that particular time, right, you may not be able to destroy everything and then recreating it. that particular time you don't want to run the scripts whatever you created, which actually ran and bootstrapped everything, right? You will barely touch it. You will never touch it. What we will do is, right now, it's all about you making a change, and then I want that change taking, and then it's going to affect all the environment or all the components, and then take it from one environment to the other environment to other environment. So that is your day two, day one. Day two is the real hard thing, which is you gone live, and you cannot even afford to have production or downtime. And this is the phase which is going to be really really challenging, because the moment you want to roll out change, right, whatever scripts you had on day zero and day one, right, that's never going to work, and you'll never run those scripts also. You'll find a new strategy. That strategy is nothing but logging into the machine, directly putting it, because none of the scripts whatever you had on day zero and day one is going to help you. So what is the solution? Or before going that, right, these are the symptoms. If you face any of this, right, actually you're not organized your components properly. One thing is, right, the first one, uh, when you're trying to change something to database or upgrading, right, and suddenly you see some changes happening to your Kubernetes cluster, or when you're trying to do some changes to your networking module, and then something like you're just changing Grafana dashboards, right? Or how many of you face this when you're trying to create this entire plan, Terraform plan or whatever, right? And suddenly Amazon is throwing you saying there's an API rate limit happening, because you're trying to change all the components together or trying to do a plan for everything, and it's making so many API calls, and AWS themselves are saying, hey, you're making too many calls to me, I'm going to rate limit you. If you have any of this, right, the problem is just the pure component organization. So I'll just quickly talk about the solution for this. It's all about how you package all your components together. There's a terminology called a stack. I think if you read infrastructure as a code book from Keith Morris, he would have defined the term called stack, or defining your own components, right? So I'll also recommend you define your own stack. It's you are the good person to know, define what is the boundary of your stack and everything. So define that, and then you should be even in a position to do this. What this is doing it right, I should able to take Kubernetes changes, I should able to roll out to dev, but I should able to make changes to databases, and I have actually taken it to dev, I've taken it to QA, now it's in staging and some people are testing it out. Each and every components individually you will able to deploy it in any environment, or the changes is progressed from one environment to other environment, and each and every environment is not touching to each other. You need to be in this state. Again, I'm saying, think of this, your day zero is only happen for this many days, and day one will happen only for this many days, but your production is going to happen, keep on happening. So don't optimize anything for day zero or day one, only try to optimize it for day two. Cool. So far we saw some of the anti-patterns, which has actually caused all the 5 different symptoms what we saw earlier, and then we kind of said how can come out of that. And these are some of the patterns which are going to talk now, which is going to help you to further solve that particular symptoms. So the first one is code organization. Same thing. This is what Sai spoke the last thing itself, right? I'm again saying this is also applicable to infrastructure. The first principle, what I'll say is, right, single responsibility principle. If you're writing a Terraform module, or I'm just taking Terraform as an example, it could be anything. If you're writing a module, right, just focus on that particular module, just doing one particular job. As an example, what I've shown here is, right, if you're using a spanner, right, you just use it to just tighten the nut. Don't use it as a hammer. It's not going to work, and this particular thing is also going to break, right? Have a defined responsibility for that particular module, and just do just that. Second, how many of you have a phone, and let's say if your battery goes off, and if you want to change your battery, but unfortunately if you're on an iPhone or an Android phone, right, only you will able to put that particular battery, then only it's going to work, correct? The same thing is happening even with our infrastructure code, right? Uh, think of this: you have all cloud providers, AWS, Azure, GCP, and everything, right? But underlying what we need is a Kubernetes cluster. Kubernetes cluster is a Kubernetes cluster, correct? What it needs is a set of master nodes and set of worker nodes and a specific version of Kubernetes. But each and every cloud provider has their own terminologies, correct? AWS will say EKS, GCP will say something, Azure will say something, DigitalOcean will say something, right? But end of day is all Kubernetes cluster. Now, instead of you are demarketing everything as a different things, if you can abstract away all those terminology away, and if you can write a model in such a way that it's a Kubernetes cluster and it only takes in variable as such, what's the version you need, what is the number of nodes you're looking for, and internally if you can translate that to the corresponding cloud provider, if you can write a module like that, then it is very easy to replace that particular thing with any other Kubernetes cluster in any other cloud provider. So think of that, and when you're writing a module, right, think of that. Inversion of control. How many of us actually face this? This is like this. When you try to change module input or output, right, and you're figuring out saying, hey, this particular module is getting input from a lot of places, and if you want to decouple this, right, I need to go change there, change here, and then I need to take out and everything, right? So inversion of control talks about this. You don't have to pass on values between each and every module. So instead, again taking an example of Terraform, in the Terraform you have an input and output. That output all gets saved in a state file. So read the output from the state file where you need it, rather than you passing around all the values everywhere, right? So go to the Terraform state, read the output, what the other modules has produced, and read that particular value and then use it. So consume it where you need it. So if you just inverse that, right, you'll never get into this problem. It will be all looking very cleaner. Fourth one, open close principle. Same thing, whatever I said, right? I'm also want to repeat the same thing, right? Your module should be open only for an extension. It should never be, but should be closed for modification. Uh, so give an example, right? Let's say I am taking in Kubernetes as an example. So if you're writing Kubernetes module, it should be closed for modification, but it can be open for extension. So what I mean by that is, right, let's say you forgot to add a node, adding multiple node pools, right? That particular feature you forgot to add at the initial place. It is an extension to that particular module. Very well, you can go ahead and do it. No, I forgot to create the VPC itself. Can I do that? No. That particular module is not supposed to create VPC or subnet. That particular module is supposed to create Kubernetes cluster. Just deal with that and just do that. And then just use it for extension. I'll say dry, same thing. So don't repeat. Try to avoid redundancy as much as possible. So this will typically happen, right? Hey, I have all the Terraform scripts with me. I have created a dev environment. Now I need to create QA environment. So typically what we'll end up trying to do is, right, we'll copy all the modules and create a directory called QA, and then we'll put it there. And then for staging, we'll put it there. But ideally, if you think of it, right, only your input file should have changed. You should have never copied that module into different environment itself, right? So like that, you can apply this principle all over the place across infrastructure as code, not only to that particular thing. So just remember that all the development practices are applicable to infrastructure as code as well. And last pattern which I'm going to say is going to help you is Yagni. Actually seen this when you're writing Terraform module, right? You become overwhelmed and then you'll say, hey, I'm going to introduce a variable for this, output for this, and then you literally create each and everything, right? You would have introduced a variable. And somebody who's consuming your module, right, they need to figure out, hey, I need to give all these variables, then only it's going to work. So don't do that, right? So just expose whatever variable is just needed, right? Just do that enough. If the need arises, then expose it out, right? So for example, let's say if you're calling a plumber or someone to come to your home and then doing it, right, think of it, right, if he's bringing all these tools to you, you'll say, hey, I asked you to just do this, but why are you bringing all these things, right? The same thing. Cool. So one more pattern which I'll quickly talk about. Uh, all the scripts concerned. Uh, if So what I mean by this is similar to what you have dev, QA, staging, right? You have another account, and then that particular account you just do this, right? It's a self-destruction environment. You have a CI/CD pipeline. You keep on running all your scripts again and again. You define the frequency. It's a day, weekly, fortnightly, whatever be it, right? But use something like AWS nuke, and then destroy all the resources what you create in the account. But again, you recreate all the script using scripts. You create all the resources again destroy it. You keep on doing it unless you do this right. You'll never figure out that what's going to break, and then that floppy disk will one day will come back. But if you use this right, that floppy disk will never come back. And this is a recent one, which is in Terraform Cloud, which they've recently introduced, which is called time-based environments or something. So what they do, right? If you give a certain point in time, after that, that entire workspace or whatever you created, right, will automatically will get destroyed. So Terraform, they will simply issue Terraform destroy. It's a time-based workspace. So these are techniques which you can actually apply, and then you can actually take it up. Yeah. Thank you very much for listening to us.